Hello, this is your first installment on how to solve system of equations. Today we're going to be looking at graphing. Now, what you need to realize is that solving system of equations basically involves figuring out where two lines cross and meet. That meeting point is the solution. Now, up to this point, we've sort of worked on these system of equations being graphable. And essentially, they're always graphable. It just might take some work to make it graphable. So, um, when I said you should know how to do this, basically, you should know how to graph this line, you should know how to graph that line, and then where they meet, again, that crossing point is your solution. So what I'm going to do is, or what I have done already, is in the packet, there's a written description on how to solve a particular system of equations. For the first three examples, it's always y equals 2x plus 4 and 2x plus 2y equals 14. In those first three examples, you always get the same answer, which is beautiful. That's what we want because they're the same lines. So we should get the same answer. And the answer is the solution, parentheses, or the ordered pair 1, 6. 1 for the x, 6 for the y. And so, anyway, this fourth method that we have, you could do um, for this system of equation, but it would involve a trick. And for this last solution, what I really want you guys to look at is a super easy way to do it if it's set up in a specific way. So, um, the idea here with these series of videos is this one's going to do graphing, and then I will release three more that will show you how to do the other three methods. Um, I don't know when these are going to come out. Hopefully, today you'll get another one. Um, and then the other two tomorrow. Maybe this one today and then three tomorrow. It just depends on how fast I can get this edited and back out to you because, again, I'm no pro. But anyway, um, I'm going to show you again an alternate system. It's not the same one that's in your packet. I'm going to show you the steps to kind of go through so you see it live. So you got one on paper you can watch, you got one that is in video form so you can see it kind of happening live, what I'm thinking about when I'm trying to do these. But basically, when you're trying to do the graphing method, there are a couple of times where it's very useful. There's some other times when it can be not as useful and it may just cause you to do extra work. So, um, the key thing to remember is if you like a specific way on how to solve a system of equations, you can always use it. Okay. It will always work, but it may not always find you the exact answer, except especially with the graphing. That's where it can be a little bit tricky. But anyway, if um, you find a specific way and you like it and you can use it and you understand how it works, you can always do it that way. It just might not be the easiest. So when is graphing usable, easy? It's typically usable and easy when you're given both lines in y equals mx plus b form. You can graph it real quick, graph the other one real quick, boom, find the answer, find where they meet, and you've got it. Um, where it can run into problems is that that meeting point may actually not be nice numbers. It might not be whole numbers. It might be the x is in between 1 and 2 and the y is in between 5 and 6. If that's the case, you have to redo it with one of the other methods to find the exact answer. So that's where it can be problematic. Where I also see it being problematic is if you have very large numbers for your slope, your m, or very large numbers for your y, your your y-intercept, your b. And so anyway, these big numbers mean a big graph, and it's going to be hard to do that. So my recommendation is, if your slope gets any bigger than about 10, your y-intercept gets any bigger than about 20, I would probably think about using one of the other methods to do it. So anyway, with that being said, we're going to go over the graphing method. Graphing method, again, is the first 2 pages of your packet. The whole first page is just a sample problem. How does it work? And then basically what I'm going to show you here on the board behind me is that in live time, it's just a different problem than is in your paper, just so you have a different one to look at. So again, let's look at this problem and kind of work through it. So we have y equals 4x plus 7, and we have 4x plus 2y equals negative 22. This first one, right away, you should recognize as a line. This one, not so much, but what we've been working on in Unit 5 is to change this to solve for y. And when we solve for y, it's going to be in y equals mx plus b form. So we'll do that in just a second, but let's just go ahead and graph this one using the techniques we learned just before we went on this COVID break. Basically, that 4 right there is the slope, okay? It's also called the M and is the rise over the run. And so for this particular one, remember we can always change that to 4 over 1. And that just tells me I want to go up 4 and right 1. I can also go down 4 and left 1. This is a positive slope. And again, positive slopes always run up and to the right. So let's go ahead and get this one up on the graph. But remember this guy here, that is the y-intercept. And it's typically easiest to go ahead and graph the y-intercept first and then run your slope off of that point. So 1, 2, 3, 4, 5, 6, 7. There is positive 7, the y-intercept for the first line. And then we're going to go up 1, 2, 3, 4 over 1, up 1, 2, 3, 4, and over 1. And then we probably want to go down 1, 2, 3, 4 over 1 to the left, 1, 2, 3, 4 over to the left, 1, 2, 3, 4 over to the left. And let's do it one more. 1, 2, 3, 4, and over to the left. So if we draw this line, should look something about like that. So let's go ahead and make our dots nice and connected there. And then what we want to do is do that 4x plus 2y equals negative 22. So again, 4x plus 2y equals negative 22. This one, again, we've got to get the y by itself. We've got to isolate the y. Okay, solve for y. And so I want to get rid of the x. Take away 4x, take away 4x. Some of you guys draw your little wall, however you prefer to do it. That's going to go away. It's going to leave me with 2y equals negative 4x minus 22. Okay, and then what I want to do to get the y by itself, again, divide 2 off of there. Whatever I do to the left side, I also have to do to the right side. So that leaves me with just y. Negative 4 divided by 2 is negative 2x. And negative 22 divided by 2 is negative 11. Now, I know how to graph that. Okay, I go to minus 11. 1, 2, 3, 4, 5, 6, 7, 8, 10, and 11. And then I go down 2, right 1, down 1, 2, right 1. Okay, well, I'm going to see right away that if I do that, it's not going to do me any good to do more points over here. So let's go up 2 and left 1, up 2 and left 1, and up 2 and left 1, and up 2 and left 1. And we can see that that guy should run about like that. The key is, where do they meet? Now, if we look here, we go -3 to the left and down 1, 2, 3, 4, 5. -5 there. A good check is to plug these back in and see if you get a true statement. Does -5 equal -2 times -3 minus 11? Well, that is 6. 6 minus 11 is -5. And once you check that, you know that that is indeed your answer. So, anyway, I hope this helps. I hope you have a good time with these first two problems I think there are in this particular section. I'll try and get a video out on the next section shortly. But if you have any questions, again, what is it? tyrick@auhsd.net. All right. Get a hold of me if you need some help.